Well, hello there and welcome back for more Advent of Code. So today we are continuing just where we left last time. And by the way, look at this, we are at 26 golden stars. That is more than halfway there. That's very cool, but we shall persist. So this will be day 14, regolith reservoir. What is regolith? Is it like... It sounds to me like it's like the material on the surface of the moon, but I'm not sure. Let's search for regolith meaning. Regolith, a region of loose unconsolidated rock and dust that sits atop a layer of bedrock. Okay. Regolith also includes soil. Okay, so it's a more general term than just what sits atop the moon, but I guess what is on the surface of the moon is also regolith. I think because it's like material that gets blown up by meteorites impacts, I think. But anyway, let's read what the 14th puzzle is about. So the distress signal leads you to a gigantic waterfall. Okay, actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Okay. Correction, the distress signal leads you behind a giant waterfall. Okay, it's still a surprising exclamation. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could quickly become trapped. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. So yeah, this is a reference to a previous puzzle of 2018. Reservoir research, but I didn't do this, so I have no idea what this is about. So I wonder if this is some sort of like sand simulation thing, which I know that some like pixel art games do. It's kind of it's a nice thing to like animate and see, and pretty like they can be done in pretty simple algorithms. So I wouldn't be surprised if this is about that. So, you scan a two-dimensional vertical slice of the cave above you, your puzzle input, a two-dimensional vertical slice or something like this, and discover that it's mostly air with structures made of rock. Okay. Your scan traces the path of each solid rock structure and reports the XY coordinates that form the shape of the path, where X represents the distance to the right, and X and Y represents the distance down. Okay. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point. For example, these. So I guess these are line segments connected by arrows. Okay. This scan means that there are two paths of rock. The first path consists of two straight lines, and the second path consists of three straight lines. Specifically, the first path consists of a line of rock from 498.4 through 498.6, and another line of rock from 498.6 through 498.6 and through 496.6. The sand is pouring into the cave from 500.0. Okay, so this seems to be 0 indexed. That's good. Drawing a rock as a hash and air as a dot and the source of the sand as a plus, this becomes this thing. Okay, so I guess this is the first segment, and this or path as it's called here, and the second path is this snaky thing, and this goes from 0 to 9, and I don't know why this is starting like from 500, so I guess the slice would be very long horizontally. But okay, and sand will pour from here. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. Oh cool, that's a nice simplification, which I don't know if will be invalidated in part 2. A unit of sand is large enough to fill 1 tile of air in your scan. Okay. A unit of sand always falls down 1 step if possible. If the tile immediately below is blocked by rock or sand, the unit of sand attempts to instead move diagonally 1 step down and to the left. If that tile is blocked, the unit of sand attempts to instead move diagonally 1 step down and to the right. Sand keeps moving as long as it's able to do so. At each step, trying to move down, then down left, then down right. If all 3 possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. Okay. So yeah, it seems like it is a sand simulation and explained in pretty simple terms. So drawing sand that has come to rest as O, and the first unit of sand simply unit of sand simply falls straight down and then stops. So yes, okay, it falls right here. The second unit of sand then falls straight down, lands on the first one, and then comes to rest to its left. Okay. After a total of 5 units of sand have come to rest, they form this pattern. Okay, pretty. After a total of 22 units of sand is this thing, which is pretty filled. Finally, only 2 more units of sand can possibly come to rest. Okay, so the first one comes here and goes to the left and then down and here, so it rests here, and the next one comes all the way to the left here and then down and rests here. Once all 24 units of sand shown above have come to rest, all further sand flows out the bottom, falling into the endless void. Just for fun, the path any new sand takes before falling forever is shown here with tilde. So yes, it goes all the way to the left, then falls here, then to the left again, and slips right through. Okay, using your scan, simulate the falling sand. How many units of sand come to rest before sand starts flowing into the abyss below? And okay, get your puzzle inputs. Okay, look at that. These are much longer paths. I'm curious about the numbers though. It seems like all the x coordinates are very close to 500 for some reason. I wonder if this draws some sort of interesting pattern. But okay, let's get started. So let's go to Projects Advent of Code 2022. Fire up the text editor and create an input in file for the inputs. Day 14 txt. Was that a comma? Okay, let's do first the sample inputs, I guess. Although it won't be too hard to parse, like compared to the actual input, but maybe this is easier to debug if we make any mistakes. Let's also create a new model for this. This would be day 14, which is called, what was it called? Regolith Reservoir. Regolith Reservoir. Right? Is this the way? Reservoir, yes. Let's copy this and let's use this here. Let's create a file also named that way, .rs, and the classic public function run that takes an input, type string slice, and returns a string and we just return this into string. Okay. All right, so how do we parse this? This is another one of these cases where the input is like more complicated than necessary. You know, these are like, the first line contains two like path segments, you could say, that are either horizontal or vertical, but this could have come in the shape, you know, in a shape like this, and it will be easier to parse because, you know, each line would contain only a pair of points, but well, we have to parse this instead, which I guess shouldn't be that complicated. So let's see. We're gonna do input lines, and for each of these, what are we going to do? I guess we have to parse the path and then draw it into a line, into a map. Yes. Actually, before declaring the map and that kind of thing, I'm interested to know in the real inputs, like what are the minimum and maximum coordinates for this, to have an idea of how big the map should be. So let's do lines, and we, I guess, could do let path be parse path for this line, and yeah, and let's declare this function. It will return, what will a path be? Well, it will be a vector of points, I guess, and the point is just gonna be a tuple of usizes, I guess, and I'm using usize here because we are going to be using this to index into vectors, I guess. So okay, how do we parse a path? I guess we're gonna get this line and split by the arrows, so by this, and for each of these, I guess we can map to, we're gonna have a point. Well, we could just call it parse point, you know, very good, and do some good modularization of the code. And here the language server doesn't suggest to to generate a function for me. So this will return a point. And what are we going to do in the parse point thing? I guess we are gonna split by comma. So let xy is gonna be x split once by a comma, and then I guess we can use a character here. I think it's the same thing though. I'm gonna expect this point should have a comma, and then we are just gonna return x parse and not s, x parse and y parse, and we're gonna expect this to expect x should be a valid number, and same thing here, expect okay. Let's simplify this. Fine, okay. This should give us all the points on these paths. So let's, I guess, print these things to see if we are parsing them correctly. So we're gonna print the path, cargo run 14. Okay, it looks fine to me. All right, so let's also keep a record of the mean, like the minimum and maximum. Like I just want to know which is the minimum x and minimum y values, to know like the size of the map. So and also I guess we can go to the input and see if there is any minus sign. Well, it is just on these arrows, but I don't think that there are negative coordinates, which is good. Min x and min y, I guess. This we can initialize to usize max and usize max. Do the same thing, but for max x and max y, and initialize to the minimum values, which I guess would be 0. Let's do then for x and y in path. Let's do min x is gonna be min x, and keep the minimum with this. Same thing with y. Yes, and then do the same thing with the maximum values. So okay, and of course this thing should be mutable, so mute, very good. And then let's print these things. Println. So we're gonna have min x and min y, and then max x and max y. Now the comma doesn't go there, it goes here. Let's run. Okay, so the minimum x value, oh, this is not the actual input. Let's copy the actual inputs into here. What did I touch? Okay, save and run again. Okay, so it seems like, yeah, the minimum x goes from 400 something to 500 something. That's interesting. And the y values go from 14 to 161. Pretty interesting. So let's go Simona. So I don't know if it makes sense to draw a map that is too big, like starting from 0 in the x coordinates, if we are only going to be having things around the 500 coordinates, right? I think so. Okay, what should we do next? I guess one thing that I would like to do is to draw these paths on a map, and then draw them up to string to see if the actual input has some sort of interesting pattern or something before doing the simulation. So let's try to do that. Now, should I use a map that starts from 0, 0 and goes up to this. Well, maybe. Let's keep this min and max calculations though. Iter. So just in case we need those. This is not called a grid or map. I think this thing is called a slice. Yes, okay. So scan slice, I guess we could call it. This would be a vector of vector. And what are we going to put here? I'm not sure. I guess we could use an enum for this for the elements of this map. Actually, let's call this thing map because I'm thinking it in terms of like a map. So the width, we have seen that the the maximum x value is 578. So let's make the width be 600 and let the height be what was the maximum height here? 161. So I guess we can go with I guess we could make the map have these dimensions, right? So and not hard code stuff. So I guess we could have something like this would be what, max x plus 1, and this would be max y plus 1, I think. And yeah, but let's actually keep then the, let's drag this into variable. I can actually do map parse path. So here if we call these things paths, okay, fine. And then how do we draw this map? Well, let's go again. Let's repeat some kind of loop like this and draw this. Or actually, the map should not be filled with zeros. I guess we can use an enum for this. Enum tile. I don't know how this is called. Like. Yes, tile. A tile there in your scan. Fine. So each tile could be air, sand, or rock. So we're going to, as usual, using tile. Now use tile. Use all the names in here for convenience. So we are going to initialize this vector with air. Then we're going to draw, oh here we shouldn't consume this, so good. Oh, let's collect the paths into a vec. Then we're going to iterate these paths. Fine. and you don't like this because this thing is not clonable, of course. Let it be clonable then. So derive clone. Okay, the map should be mutable. And then let's write these things into these path segments. So actually, for each path, we should be iterating over each segment of this path, which will be like pairs of 2. So we can use the Windows function for this. I'm pretty sure that you cannot use something like starts and ends. Let's see. Can you iterate over this? Refutable pattern. Can you do something like this? For let doesn't exist, right? Yeah, no. Okay, so let's do actually we could extract this start and end and extract this thing into like a function called path segments. Just gonna it's gonna take a vector of actually a slice of points and return an iterator of pairs of points. Right? Yes. So we're gonna have this Windows thing. Consider borrowing path. Yes, of course. See like this. And here, for each window, we're gonna map this to, well, the window, and we are just gonna use good old indexing. What's your problem here? Hidden type for input blah blah captures lifetime that does not appear in bounds. Oh, I think I had to do some weird thing here to declare the lifetime of this. Yes, I don't really understand this lifetime declaration here, but let's roll with this. So okay, here we should be iterating over each path segment. So let's draw this into the map. I guess we could do something like, well, we're gonna have start and end. We could actually destructure this here. So we're gonna have x1 and y1 and x2 and y2. So lines could be either horizontal or vertical. So if x1 is equal to x2, then it's a horizontal, it's a vertical line. So we are going to do, well, I don't know if the input always goes from a short, like from, how do you call this? Like if the left part of each segment is less, for instance, here it goes from 491 to 493, that's good. And here it goes from 493 to 495, but I'm not sure if it's always like the left one is bigger than the right one. 497, 499, it seems to be following a pattern here, right? Yeah, or maybe I'm crazy. It looks like a stair or something, but let's not interpret these numbers like crazy. Let's draw them to the screen and see. So we were here, x1 is equal to x2, then this is a vertical line. So let's do something like for y in, we're going to go from the minimum of the y's, so y1 min y2. Actually, I think there is a min max. No, min is fine. Then we are going to go from, well, including y1 max y2. Okay. And then we are going to, in the map, we're going to put a rock here in y, and we can use either x1 or x2 here. It should be the same. This should be rock. Okay. Else, if y1 is equal to y2, then we're going to do something similar. But if the y coordinates are the same, this means that this is a horizontal line, so we can do this. We're going to advance in x from the minimum of the two to the maximum of the two, and use y1 here and just the x vertical line, and this should be a horizontal line. And else, let's panic and say line or path segments should be either horizontal or vertical. Good. Okay, so I think with that we should have the map written. Let's see if it explodes. It does run without errors, that's fine. Let's draw it to the screen and see what we got. So I guess we can do for row in the map. So for each row, we're gonna print line. Well, let's let line be row iter map. So we're going to map each tile. So here tile I think should be reference to tile. Yes, good. Well, let's say well, let's match. Here we should only have air or rock. So let's say if it is air, then map it to space, and if it is anything else, map it to a hash, and then join. Can you join things like, actually line could be a string and we just collect. Oops, don't you like this? Oh, because what are we matching? We are matching the tile. Okay, and then we should print line this thing. All right, let's see what gets printed. Actually, let's use the other console. Cargo run 14. We did get something. Let's maximize this and maybe lower the size. Oh, damn it! You probably cannot see the top because of my head there. Let's let's ignore the first 500. So this started at what was 400 something, so let's actually get the row starting from 400 till the end, and let's run this thing again. Look at that structure. That is very, very interesting, very pretty. We can increase, I guess, the font size maybe a couple of times. So look at that. This is going to be a very pleasing feeling pattern, I guess. Now I am tempted to implement like an animation for this, because it's going to look rather pretty, I think. But okay, we know then that the actual input has some very interesting patterns in here. And I guess this would be a very good challenge to actually implement like by hand. You know, like you could print this and then, you know, draw by hand how these things would be filled and then count the things. But anyway, we are implementing with computers. So, okay, we have parsed the input and drawn this map. That's very good. Let's comment this drawing code. What else do we need here? Well, I guess we have to do the simulation now. We have already successfully parsed this. It's not maybe the prettiest parsing function. We could, I guess, extract this into a parse map. Yeah, let's actually do that. Do we need anything more? No, not really. So let's extract this into a function, parse map. We're going to take the inputs, and this is going to return a vector of vectors of tile, and return the map. Okay. Let's put the paths in here first. Then we calculate the minimum and the maximums. Sure. And then we make the map full of air. And then we fill that map with the rock paths. Cool. Let's move also this commented code in here. Sure thing. Okay, so we have some warnings all over the place. Oh, I guess because we are not calling a lot of these functions. Let's put these path segments in the end. So let's say let map be parse map. We're going to pass the input. Great. And then we are going to do the simulation. So how are we going to do this? I guess we could loop until we loop and drop each grain of sand one at a time until the one falls into the void. And as soon as one does that, we break out of the loop, right? I guess we could do something like drop sand grain and pass the map, and this could return like a boolean, or actually this could return the place where the sand will finally rest and be optional. So if it returns none, it means that it went through the void. And I guess if we do that, we, instead of writing a loop, we could say while let some xy will be the resting position of the grain of sand. And if there is a resting position, we can draw it through the map. So we can pass the map here as this map will need to be mutable because we need to still write sand to it. But here we can pass it immutable, and then if there is a resting position, we can write it into the map. So map y x is gonna be send, and we can increment a counter for this. So let's mute send, well, yeah, send brains count be 0 and increment this. Send brains count plus equal 1, and then we just print this thing in the end. So formats this, right? You don't like this? Oh, I don't know how I managed to break this. You don't like this before? Send brains count. Okay. And can you generate this function for me? So look at that fancy. This is not exactly what I want, but fine. Vector of tiles. Yeah. And this will return an optional point. Okay. So what are we going to do then? Here we are going to have, I guess, the mutable x and y, where the position of the grain of sand, and we can start this. It starts at 500 0, and we are just going to let it drop until it goes out of bounds or it finds a resting position. Yeah, so that's. So let's loop. Yeah. So, one second. How do we do this? Well, we could ask. We will try to go down left or down right, right? So we could say those are the preferences. So I guess we are gonna have down would be x and y plus 1. Down left would be, sorry, I'm a bit derpy, x minus 1 and y plus 1. And down right will be x plus 1, y plus 1. Yes, and this thing yeah, we don't need to do intuitor if you're going to do. I guess we can shadow these variables. So these are the preferred positions to go in that order. So we can ask if the map at we had to do some bounds checking also before, I guess. And I don't know if we need to check for underflow here for the x coordinate, because all of this is shifted to the right, so like near 500, so I don't think underflows are going to occur here. Maybe we don't need to worry about that. Although we could have out of bounds access of x in the right direction, because, well, I guess we could, because we are creating this map, where was it? Here, to just include that plus 1. So, okay. Maybe we can do something like if y is greater than, well, greater or equal than map length, then return none, because this means falling into the void. And otherwise, y will be in bounds, so that's fine. And let's not worry about x being out of bounds. We can maybe extend this and do +2 here. So if the map at x and y is air, I guess we can continue, right? Well, wait. Yeah, no, we shouldn't call this thing x and y because we have to update these other variables. So let's call this next x and next y. So if this thing is air, we can move here. Otherwise, we will continue on trying this, right? So I think that this if condition we should probably not go here, and I'm having a bit of trouble thinking about this. Maybe this if condition should go here in this loop, or no, here we are going to update this, so after this we are going to check this, I think. Yes. Okay, so what do we want to do? Let's say if this thing matches air, then we can move here and we can do x equals next x and y equals next y, and break out of this loop. Otherwise, well, otherwise we are just going to continue. So yes, this is so the following case. Oh no, actually, if we don't update any of this in this loop, then it means that we have to return, like the sand should stay at the current xy, I think, because it cannot move into any of these directions, right? I think so. So yeah. It's actually, I'm finding this to be a bit trickier than I thought to think about. I guess we could do something like, let's mute next position be none. And yeah, so if any of this is air, I guess we could find in this we find the first one that is air, and if we don't find anything, then it means that we should get stuck. So yeah, let's express this in a more convenient way. We're gonna do this thing into iter and find, yes, let's find next x. Well, here we can actually say xy. Where it matches, where it's empty, it's there, so we can fall through. Oops. Yes, okay. Something like this. Let's empty tile. Okay. And you don't like this because these are probably references now. Yes, okay. Just do dereference. Good. Empty tile. So if there is some empty tile, next x and next y, empty tile, then we can do x is next x and y is next y, and we have updated the y, so here if yes, if we go over the map length, then we have fallen into the void. Good. Otherwise, if there is no new position, we are going to return the resting position. So this would be the current xy, because we cannot advance anymore. I think that's what I want to do. Man, this thing is pretty simple logic, but I derped quite a bit. Maybe we can use some earlier return here. Let's say let's some blah blah. Else we're gonna. So if there is no next x and y, we can do something like this, I think. Yes, so if there is no empty tile to go, this is the resting position. Sand rain should rest at xy, and otherwise it's falling into the void. Very good. Let's see if this actually works. We can maybe start with sample inputs and run this thing. Panicked. Index out of bounds. Okay, which line? I wonder if this is the y or x axis index. So can we maybe length is 10, but the index is 10. This sounds like the y. Ah, yes, okay, because here we are trying to go one further. So I guess we could, when we update this, Yeah. When we are 1 away from the length of the map, this is still a valid index, but let's create then the map to have an extra coordinate here, and I think we are going to need the same for the x, but let's try this first. Okay, 24. Was this the correct answer for the sample inputs? Yes, it was. Okay, let's then try with this gigantic. Yes, look at this. This will surely overflow somewhere, probably here. So let's try it with the actual inputs and see what happens. Okay, it didn't explode. Let's try this answer. Yes. All right, very good. I guess the sun grain dropping code is all right. I'm pretty happy with this. The rest of the code, maybe not so much, but yeah. Okay, let's go to R2 and see what happens. You realize you misread the scan. Oh, shoot. There isn't an endless void at the bottom of the scan. There is floor, and you're just standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y coordinate equals to 2 plus the highest y coordinate of any point in your scan. In the example above, the highest y coordinate of any point is 9, and so the floor is at 11. This is as if you scan continued one extra rock path like infinity. Okay. With the added floor, the example above now looks like this. Alright. To find somewhere safe to stand, you need to simulate the falling sun until a unit of sand comes to rest at 500, 0. Aha, blocking the source entirely and stopping the flow of sand into the cave. In the example above, this situation finally looks like this after 93 units of sand come to rest. Aha. Using your scan, simulate the falling sand until the source of the sand becomes blocked. How many units of sand come to rest? Okay. Interesting. So we have to do basically the same simulation, but with we could probably reuse the same code, but use a different map. It has an infinite floor, or we could draw the floor starting from x1, because the highest y coordinates was, or deepest y coordinate was like the less than 200. So I guess if you have a pyramid, starting with a center at 500, then it won't go further than x equals 300 to the left. So that should be good, I guess. Very cool. And how many units of sand come to rest? Okay, and we have to do the same calculation. That's very good. So here we parse the initial map. Then we can do the part 2 map and run the same simulation. Okay. I wonder, I would like to express this falling into the void in maybe a better way, and without needing to do like +2 here when parsing. So this would be, yeah, we could maybe do this here. So we're always going to do y plus 1 here. So we could say if y plus 1 is the map length or greater, then we have fallen into the void and we can return none. And we do this before accessing this here. Yes. So I guess with that, we shouldn't need to do +2. Oh, but actually we are going to need to have a lot more space on the x coordinate to do the full filling of the thing. So I'm wondering if this should just be a map of, you know, a fixed width here, like 1,000 or something. That seems like a nicer approach, but okay, with that change, we have the same answer as before. That is good. I think that is the same answer, right? Yes. Huh. Let's do then how are we going to do part 2? I guess we could, let's think. This is going to be, so the map that we did is already one more than the maximum coordinate, because, well, actually the coordinates, what's up with those coordinates? They do start at 0 index from the input. So, well, it's going to be either like a off by 1 error. So let's try to do the second part. Let's mute part map with floor. We could, I guess, clone this map and then extend it. Probably. How do we do this? So, let's do something like the first map. We can, well, actually, we have already mutated the first map, but what should we do here? Because also we could use the same map for both parts, and the first part could be yeah, it could be, you know, doing this simulation until we find a grain of sand. Like if this xy is touching the floor level, then we stop the count there. And then we do like we keep filling the map until it touches the 500 0. That's another alternative. So there won't be any falling into a void, I guess. But okay, let's try to draw the map with floor. So we're gonna have basically the part 1 map. Let's see. Actually, yes, this input. I think we are going to copy this code for rendering the map to see that we are rendering the map with floor correctly. So what do we want to do here? I guess we can extend this. Actually, screw it. We are going to create here a fixed size of 1000. Yes, and here we go up to there. It should give us the same answer. Yes, no problem. And here we are going to, well, clone this thing, I guess, or we could just add the floor, at the bottom. So we can say map. Let's push. Let's actually, let's push like the floor. Let's floor be a vector of rock of 1000 units, and let's push this floor layer, and let's write this. Let's print this thing. So if it is air, then let's draw a dot. If it is sand, let's draw an O. And if it is rock, let's draw a hash sign. And let's print this thing. Well, actually, let's print it in this console. And we can, well, instead of using the long input, let's use the sample input. Save, and we can maybe print from 400 to 600, and see if we draw the floor correctly. So let's do it here. Let's decrease the size. So no, we need we need a layer of air and a layer of a layer of air and then the floor. So let's actually do it like this. Run the same thing. Okay, I think now this is how it should look. Perfect. And it's already kind of filled with sand. So I guess we can do the same thing. We will keep dropping grains of sand, but now let's keep, let's say, part 1 answer is this sand grains count, or part 1 count is this, and then for part 2 we're going to print the total, I think. So let's do the same, and if we do it now, it's gonna, do we have the sample input? Yes. If we do it now, I think it's gonna fill until, well, I don't know what's gonna happen. It's actually running without ending. Interesting. thought it should probably underflow in the x coordinates, but I don't know why that is not happening. So we need a stop condition here when we have an infinite floor. I wonder what was happening there. So they should come to rest. Interesting. So yeah, maybe it got stuck at some point when it's resting. Yeah, on the first position, and it can no longer go anywhere. It's going to be always returning some in the same position. So we put, let's see, when this is filled, then we can maybe ask here if xy equals 500 0, then break. Let's run now. Okay, 93. Is that the correct answer? Yes. So let's run with full inputs. 20,000 grains of sand. Submit. And yes, okay, another golden star. Very nice. So that was pretty good. Let's see. If we can improve something else. I guess in here we are not going to. We're only using max y, but we don't need the min x or max x or anything else. And the maximum value of y, we do need that. So yeah, that is something that we do need. I do wonder. Yeah, we can see how to improve that later. But I was also wondering, like, we have here two parts where we are doing the dropping of grains of sand. Can we do something better for that? I do sort of like that we start with this map and then we are just doing the same thing, but adding the floor. And the code is the same for the dropping of the sand. We didn't have to modify this for the part 2, so that is good. Yeah, I think I sort of like this. We may probably do the dropping of this thing as a mutable thing here. And just, draw the sand here instead of returning. But we do need the break condition, right? Yes, I think we do. Let's think. Well, this is already like a convincing answer, I think. So let's add these changes. Well, not with this commented code. This is all right. This dropping, let's accept this run as it is for now. Here, I guess we only need the mutable max y. Come on, cats. So let's mute max y. Let's be this, and let's do this. Okay, here we have all the paths. Here we're getting the max y. Sure. I guess we could also do something like an iterator-based function here and do paths iter, and then we can flat map path iter, and then we are going to find the x and y. Actually, we are going to, no, it's not find what I want, we're gonna map. So this path iter is going to iterate over points. So we want to find the point xy. We're gonna ignore this and map to the y and get the maximum of that, right? And this max y is probably going to be an option of u size that we're going to expect. There should be at least one path. Sure. We don't need this to be mutable. And max y is now a reference to u size. I guess we can also dereference this. And okay. Does this still give the same answer? Yes, it does. And does it run in a timely fashion? I wonder. Target, debug, advent of code, day 14. Oh, it's actually taking some time. So if we do cargo field release and time it in release mode. Okay, I think we don't need to worry for now, but maybe we are doing some excessive computation for this. That's all right. Okay. So yes, this parsing now looks a bit better. I'm fine with this. I'm fine with this too. Let's add these changes. Here we're adding the floor and doing the same thing again. And I think, yeah, I think that should be it. I'm pretty happy with the solution. I don't know, maybe we can remove the repetition here between the part 1 and part 2 with the dropping of these segments. So if we wanted to do this, how would we do so? Because this is nice to see when we have reached the top and grains of sand can no longer fall. So yes, because once we have a grain of sand there, this is, we will have no longer an empty tile, and I do wonder, however, why does that not cause this to return none? Because the grain of sand should get stuck where it is. But I guess, oh, yes, we can do here, like, if this xy is already filled, then we cannot drop this, right? You're gonna find an empty tile. Yes, we cannot drop this here. So I do wonder if we can do this check into a more generic way, not just falling into the void, but if it's already, like, if it cannot drop at all. So if the map at x and y, or y and x, is not air, then we could return none here, and we want to need this check, which I think is fine. Yeah, because we cannot drop a grain of sand. Yeah, I sort of like that. So let's say if this matches, or I guess if it doesn't match air, then return none. Start position already occupied, cannot start, cannot drop more sand. And here we don't need to check this. And let's see, cargo run, and let's see if we keep the same number. Yes, indeed. So now this is the same code as this, and I do wonder, this returns this, okay, and we can, I guess we could just return, like, make this, yes. Let's actually go full on with this. We could receive this as a mutable map, I guess a mute reference here, and here, instead of saying this, we can say map y x should be sand, and return true, because it could drop that grain of sand. So now this thing should return bool, and here, instead of saying return none, we are going to return false. So instead of doing this, we can now, let's do this and not do this, and pass this thing, well, pass this as mutable reference, pass this again here as mutable reference, and yeah. And now, does it still behave the same way? Yes, it does. Yes, there is an empty tile, so this map becomes sand. Good, and we don't need that comment. And this is good. Yeah. Yep. So I quite like this. Maybe this could be refactored, so this doesn't need to be checked again like we are checking here, but I'm okay with that. And here the two whiles are the same thing. Maybe we could extract it into a function, but that's not really necessary, I think. We're using the same variable to count this. Am I okay with that? I think I am. Yeah, why not? We have the part 1 count and then the total count like this. So yes, I think there's nothing more than I want to improve on this answer, on this solution. The parsing of the points is also fine. Yes, I guess we could do one more extraction here and call this thing parse number, but yeah, not really necessary. Okay, yeah, let's commit this. Let's say day 14 solution. And that's it. That was day 14 with a nice sand simulation. I guess I could try to do a visualization for this sand simulation, but I will leave that for another coding session. I'm feeling already a bit fussy in my thinking, so we should end this here. And well, if you have been, thank you for watching and see you next time. Bye bye.